First, let's get our definition. A vector is a quantity that has both a magnitude, which will appear like a length when we represent it graphically, and a direction. And so we often write vector using our component form. This looks kind of like an ordered pair, but instead of parentheses, we have these brackets. And this first number, which I'm showing with x, represents the horizontal component, and y represents the vertical component. So let's say I have this vector. We'll have it start at the origin and move to this point. It goes to the right 8 and it goes up 4. So if I were trying to write the component form for that vector, it would just be 8 comma 4. And so let's get a little more basic vocab. We have our initial point for the vector, which is basically where the vector begins. And we have the terminal point, which is where the vector ends. So if I was talking about the initial point of these two vectors, I have two different vectors shown. And there's the initial point that I have there highlighted in red. And if we're talking about the terminal point, which is where the vector ends, the terminal point of both of those vectors I've highlighted in green. Super easy to identify. Lastly, let's look at standard position. And standard position is just a vector that has an initial point on the origin. So out of the two vectors we've shown, the red vector and the blue vector is the vector that's in standard position. Now, if you can, pause the video and try to figure these two out on our own. I'm giving you the initial point and the terminal point, and I want you to write the component form of the vector. I'm going to start at 0, negative 4, and I'm going to end at negative 5, 2. So there is what my vector would look like right there. I've got my initial point there and my terminal point there with the arrow. Our component form is just going to be how far it moves horizontally and how far it moves vertically. And this we can actually both identify from the graph. It looks like our graph moves 5 units to the left, so our horizontal component is negative 5, and it appears that it moves 6 units up, so our vertical component is a positive 6. What we could do to get our horizontal component, we could subtract terminal point's x value minus the initial point's x value. If I do negative 5 minus 0, that would give us the horizontal component of negative 5. And if I were to do the same thing to find my vertical component, we could do 2 minus a negative 4, which would give us the 6 right there. So you could do it graphically or you could do it algebraically. Now I'm going to erase this so we can do number 2. And now if we have an initial point at negative 3, 1 and a terminal point at 0, 0. So there's our vector shown right there in black. Firstly, to be clear about a previous definition, this is not considered standard position. The initial point has to be at the origin for this to be standard position. So for our component form here, I'm not going to do it algebraically. I'll just do it graphically, but it looks like we move to the right 3 units and down 1 unit. So our component form is 3, negative 1. Let's move on. Another definition that we need to know is equivalent vectors. And equivalent vectors have the same magnitude and direction. So for example, if I had two vectors that appeared like this graphically, they would be equivalent. They have the same magnitude, which graphically appears to be the length, and they're going in the same direction. Now these two vectors, they have the same magnitude or the same length, but they're going in different directions, so we do not consider them equivalent. And in these two vectors, they're going in the same direction, but they have different magnitudes. This one's longer, so they're not considered equivalent. Now, let's learn how to actually calculate the magnitude. The magnitude is a numerical measure, so we need to be able to find the actual number and not just say, oh, longer, shorter, whatever. I want to be able to quantify that. So our way that we find the magnitude is the magnitude is going to be the length of this. Well, if I were to draw this horizontal component and this vertical component on a graph, we see that we've got a little right triangle. So for this particular vector, our horizontal component is 8 and our vertical component is 4. And so to find the length of the vector, okay, and so if we were to call this vector v, that's our notation for it. And the magnitude, you'll see it shown with either like an absolute value symbol, or sometimes you'll see it shown with 2 of them. But if we wanted the magnitude of this vector, what we would do is we would just do Pythagorean theorem. I would do the horizontal component plus the vertical component and take the square root. In this particular situation, that's going to be 8 squared plus 4 squared, which is going to give us the square root of 80. We could simplify that, or we could just write it as a decimal. That's roughly a magnitude of 8.9. Now, to find the direction, what we do is we measure our direction as an angle off of the x-axis, kind of like we've been doing for most of our trig so far. So to find the direction, I would define that direction as this angle right here that I'm showing in green. We'll call that theta. So to find our direction angle, we're going to use our right triangle trigonometry. If you remember, if we have a right triangle here, opposite over adjacent, we have defined that as the tangent ratio. And so the tangent of a given angle is equal to opposite over adjacent. To find that angle, we could do tan inverse of opposite over adjacent, and our calculator is going to spit out that angle. I get that theta is 26.6 degrees. That is our direction. So that's how to find magnitude and direction. Let's do a practice example. If you have the component form, I want you to calculate the magnitude and direction. So pause this video, see if you can do it on your own, and then hit play to see how you're doing. So when I look at this, give us the component form of the vector, which means we're going to move to the left 6 and up 4. This component form doesn't tell us where necessarily the vector is located, so we could place this vector wherever we want. For problems like this, I like to place it in standard position. If we go to the left 6 and up 4, your vector will look like that. So as we've established, to find the magnitude of the vector, which I'll just call vector v in this case, what we're going to do is we're going to do the square root of the horizontal component squared plus the vertical component squared. That's going to be equal to the square root of 52, or as a decimal, that's going to be about 7.2. So basically, remember, to find magnitude, we're really just doing the Pythagorean theorem. Then to find the direction, what we learned on our last slide is that we're going to do tan inverse of the vertical component divided by the horizontal component. If I punch that in my calculator, it's going to give us our angle. And remember, we're looking for this angle right here off of the x-axis. Now, what you'll probably notice is that the calculator spit out to me negative 33.7 degrees. That's due to the domain restrictions on our inverse tan function. And so what that means is we're going to use negative 33.7. That would be going down in this direction. We're going to use that as our reference angle. That means that this angle, and I'll show it in purple, this angle right here is 33.7 degrees. And so if we know this angle, you can probably guess how to find the angle that we're looking for. We're going to do 180 minus 33.7. And that's going to give us 146.3 degrees. That's our direction angle. Now in this slide, we're going to go the other direction. What if I give you the magnitude and the direction, and I want you to find the component form? What I like to do initially is I like to get a good look at what this would look like. So I'm going to draw a graph. Once again, we don't know where the initial point of this vector is, so I like to put it in standard position. But we have a 300-degree angle, which would be right there. And we have a magnitude of 10. So there's our vector v. It's got a magnitude of 10. But what we're looking for is what I'm going to show here in blue. We're looking for this horizontal component, which we'll call our x. And we're looking for this vertical component, which would be our y. So what we can basically do is we can use trig to find this. The shortcut is that the sine of a given angle, the sine of our 300-degree angle, is equal to y over r. And so if you were to multiply both sides, you'd get 10 times the sine of 300 is going to give you your y coordinate. And then the cosine of our 300-degree angle is going to be equal to x over r. And if we solve that for x, we get that x equals 10 times the cosine of 300 degrees. Now let's evaluate those in our calculator. So it looks like our horizontal component is going to be 5, and it looks like our vertical component is going to be about, and I'm rounding this a little bit, negative 8.6. So our component form there is just going to be 5 comma negative 8.6. I tried to show you why with trigonometry we end up with 10 cosine 300 and 10 sine 300, but let's generalize that process. What you can do to find your horizontal component is you can do r cosine theta, and to find your vertical component, you can do r sine theta. So to summarize that last idea, if you're given a vector with magnitude, let's say r, and a direction angle theta, we can write the vector in component form like that by using this relationship. The horizontal component is r cosine theta, and the vertical component is r sine theta. So making something up, let's say the magnitude of vector v equals 42, and the direction angle theta is 312 degrees. All we have to do, if I want to convert this to component form, if I want to figure out how far left and right it goes and how far up and down it goes, all we'd have to do is we do 42 times the cosine of 312 degrees, and then we do 42 times the sine of 312 degrees, and it is easy as that. So we've covered a lot in this video. We've covered what is a vector, what is initial point, what is terminal point, what is standard position, how to calculate the magnitude, how to calculate the direction, and then if you know magnitude and direction, how to write component form. So we've covered quite a bit. I hope this video was helpful.